Using background wire in the described situation is not in compliance with the National Electrical Code. NEC Section 800.100, subsection A, paragraph 1, requires equipment grounding conductors to be insulated or covered with a continuous and readily identifiable jacket or covering where they are in an accessible location. Background wire does not meet this requirement. Background wire can be easily contacted and pose a shock hazard to personnel working in the area. Background wire is susceptible to corrosion and degradation, which can compromise its conductivity. To address these concerns, you should replace the background wire with an insulated or jacketed equipment grounding conductor. This will ensure compliance with the NEC and enhance safety. The ground bus bar inside the BET should be bonded to the TMGB or telecommunication main grounding bus bar. The TMGB should be connected to an earth electrode system per NEC Section 800.50. The bonding conductor should be sized appropriately according to NEC Section 800.40. In the event of a lightning strike, the OSB cable could indeed energize the BET. However, the proper grounding and bonding should redirect the surge current to the earth electrode system and protect personnel and equipment. Grounding and bonding are essential safety measures in electrical and telecommunications systems. They are designed to protect individuals and equipment from electrical hazards such as electric shock and fire, and to ensure the proper functioning of electrical equipment. Grounding refers to the connection of electrical equipment to the earth, providing a path for fault current to flow back to the source. Bonding refers to the connection of different metallic parts of a system to create an electrically conductive path. Together, grounding and bonding help to equalize the electrical potential within a system and minimize the risk of electrical shock. In telecommunications systems, grounding and bonding are particularly important due to the sensitive nature of the equipment and the potential for exposure to lightning strikes and other electrical disturbances. The building entrance terminal, or BET, serves as the point where outside telecommunications cables enter a building. It is crucial to properly ground and bond the BET to protect the equipment and personnel inside the building. The National Electrical Code, or NEC, provides specific requirements for grounding and bonding telecommunication systems. These requirements are designed to ensure the safety and reliability of these systems. One of the key requirements of the NEC is that all equipment grounding conductors must be insulated or covered with a continuous and readily identifiable jacket or covering. This requirement is intended to prevent accidental contact with energized conductors and to protect the grounding conductor from corrosion and degradation. Using background wire in an accessible location violates this requirement. In addition to the NEC requirements, there are also industry best practices for grounding and bonding telecommunications systems. These best practices recommend using appropriately sized grounding conductors, minimizing the length of grounding conductors, and bonding all metallic parts of the system together. When installing or maintaining a telecommunications system, it is essential to follow both the NEC requirements and industry best practices for grounding and bonding. This will help to ensure the safety and reliability of the system. The telecommunications main grounding busbar, or TMGB, is a central point for connecting all grounding conductors in a telecommunications system. The TMGB should be located as close as possible to the point where the telecommunications cables enter the building. All grounding conductors from the BET, the equipment racks, and other metallic parts of the system should be connected to the TMGB. The TMGB should be connected to the earth electrode system, which is the primary grounding point for the building. The earth electrode system typically consists of one or more ground rods, metal water pipes, or other buried metallic structures. The connection between the TMGB and the earth electrode system should be made with a low impedance grounding conductor. In the event of a lightning strike or other electrical surge, the grounding system provides a path for the surge current to flow to ground, protecting the equipment and personnel inside the building. It is important to ensure that the grounding system is properly designed and installed to effectively handle surge currents. Regular inspections and maintenance of the grounding system are also essential to ensure its continued effectiveness. The NEC provides specific requirements for the size and type of grounding conductors used in telecommunications systems. These requirements are based on the size of the telecommunications cables and the potential for exposure to lightning strikes and other electrical disturbances. It is important to consult the NEC to determine the appropriate size and type of grounding conductors for a particular application. In addition to the NEC requirements, there are also industry best practices for sizing grounding conductors. These best practices recommend using larger grounding conductors than the minimum required by the NEC, especially in areas with high lightning activity. When selecting grounding conductors, it is important to consider the potential for corrosion and degradation. Grounding conductors should be made of corrosion-resistant materials such as copper or aluminum and should be protected from physical damage. Regular inspections of grounding conductors should be performed to identify any signs of corrosion or damage. Corroded or damaged grounding conductors should be replaced immediately to ensure the continued effectiveness of the grounding system. Bonding is the process of connecting different metallic parts of a system together to create an electrically conductive path. Bonding helps to equalize the electrical potential within the system and minimize the risk of electrical shock. In telecommunications systems, bonding is particularly important due to the sensitive nature of the equipment and the potential for exposure to lightning strikes and other electrical disturbances. All metallic parts of the system, including equipment racks, cable trays, and conduit, should be bonded together. The bonding conductor should be sized appropriately to handle the potential fault current. The NEC provides specific requirements for bonding telecommunications systems. These requirements are designed to ensure the safety and reliability of these systems. One of the key requirements of the NEC is that all bonding conductors must be securely connected to the metallic parts of the system. The connections should be made with approved bonding connectors and should be protected from corrosion and physical damage. Regular inspections of bonding connections should be performed to identify any signs of corrosion or damage. Corroded or damaged bonding connections should be replaced immediately to ensure the continued effectiveness of the bonding system. In addition to the NEC requirements, there are also industry best practices for bonding telecommunications systems. These best practices recommend using star bonding configurations where all bonding conductors are connected to a central bonding point. Star bonding configurations help to minimize the impedance of the bonding system and improve its effectiveness. When installing or maintaining a telecommunications system, it is essential to follow both the NEC requirements and industry best practices for bonding. This will help to ensure the safety and reliability of the system. Lightning protection is an important consideration for telecommunications systems, especially in areas with high lightning activity. Lightning strikes can cause significant damage to telecommunications equipment and can pose a serious risk to personnel. A comprehensive lightning protection system should include both grounding and bonding, as well as surge protection devices. Surge protection devices are designed to protect telecommunications equipment from voltage surges caused by lightning strikes or other electrical disturbances. Surge protection devices should be installed at the point where the telecommunications cables enter the building and at other critical locations within the system. The NEC provides specific requirements for lightning protection systems in telecommunications systems. These requirements are designed to ensure the safety and effectiveness of these systems. It is important to consult the NEC to determine the appropriate lightning protection measures for a particular application. In addition to the NEC requirements, there are also industry best practices for lightning protection systems. These best practices recommend using multiple layers of surge protection and regularly inspecting and testing surge protection devices. When installing or maintaining a telecommunications system, it is essential to follow both the NEC requirements and industry best practices for lightning protection. This will help to protect the equipment and personnel from the hazards of lightning strikes. Regular inspections and maintenance of telecommunications systems are essential to ensure their continued safety and reliability. Inspections should be performed regularly to identify any signs of damage, corrosion, or other problems. Maintenance should be performed as needed to correct any identified problems. The NEC provides specific requirements for the inspection and maintenance of telecommunications systems. These requirements are designed to ensure the safety and reliability of these systems. it is important to consult the NEC to determine the appropriate inspection and maintenance procedures for a particular application. In addition to the NEC requirements, there are also industry best practices for the inspection and maintenance of telecommunications systems. These best practices recommend keeping detailed records of all inspections and maintenance activities. When inspecting a telecommunications system, it is important to check the grounding and bonding system for any signs of corrosion, damage, or loose connections. It is also important to check the surge protection devices to ensure that they are functioning properly. Any identified problems should be corrected immediately to prevent potential hazards. When performing maintenance on a telecommunications system, it is important to follow all safety precautions. The power should be turned off before working on any electrical equipment. Appropriate personal protective equipment, such as gloves and safety glasses, should be worn. Only qualified personnel should perform maintenance on telecommunications systems. Proper grounding and bonding are crucial for the safe and reliable operation of telecommunications systems. By following the NEC requirements and industry best practices, it is possible to minimize the risk of electrical hazards and ensure the continued performance of these systems. Remember to always consult the latest edition of the NEC and any applicable local codes for specific requirements. Additionally, it is recommended to seek the advice of a qualified electrical engineer or telecommunications specialist for complex installations or troubleshooting. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Regarding the specific concern about the bare number 6 American wire gauge ground wire, replacing it with an insulated conductor is paramount. This not only addresses the NEC violation but also significantly reduces the risk of accidental contact and potential shock. The insulated conductor provides a protective barrier, preventing personnel from inadvertently touching the ground wire and creating a path to ground. Furthermore, the insulation protects the conductor from environmental factors that can lead to corrosion and degradation. This ensures the long-term integrity and effectiveness of the grounding system. When selecting a replacement conductor, it is important to choose one that is appropriately sized for the application and meets the requirements of the NEC. The conductor should be made of a corrosion-resistant material, such as copper or aluminum, and should be rated for the voltage and current that it will be carrying. The insulation should be suitable for the environment in which the conductor will be installed and should provide adequate protection against moisture, chemicals, and physical damage. In addition to replacing the bare ground wire, it is also important to ensure that all other grounding and bonding connections in the system are properly installed and maintained. This includes verifying that the ground bus bar inside the BET is securely bonded to the TMGB and that the TMGB is connected to the earth electrode system with a low impedance grounding conductor. All connections should be clean, tight, and free from corrosion. Regular inspections should be performed to identify any signs of damage or deterioration. By taking these steps, you can ensure that the telecommunications system is properly grounded and bonded, providing a safe and reliable environment for personnel and equipment. In the event of a lightning strike, the properly grounded and bonded system will provide a path for the surge current to flow to ground, protecting the equipment from damage and preventing potential hazards. It is also important to consider the potential for induced voltages on telecommunications cables due to nearby lightning strikes. Surge protection devices should be installed at the point where the cables enter the building and at other critical locations within the system to protect against these induced voltages. The surge protection devices should be properly grounded and bonded to ensure their effectiveness. Regular inspections and testing of the surge protection devices should be performed to verify that they are functioning properly. By implementing a comprehensive lightning protection system, you can significantly reduce the risk of damage to telecommunications equipment and ensure the safety of personnel. Remember that grounding and bonding are not one-time tasks but rather ongoing processes that require regular attention and maintenance. By diligently following the NEC requirements and industry best practices, you can create a safe and reliable telecommunications system that will provide years of trouble-free service. Always consult with a qualified electrical engineer or telecommunications specialist for any questions or concerns regarding grounding, bonding, or lightning protection. Their expertise can help you to ensure that your system is properly designed and installed to meet your specific needs and requirements. The importance of proper grounding and bonding in telecommunications systems cannot be overstated. These measures are essential for protecting personnel and equipment from electrical hazards, ensuring the reliability of the system, and complying with the NEC and other applicable codes and standards. By taking the time to understand the principles of grounding and bonding and by following the recommended practices, you can create a safe and efficient telecommunications system that will serve you well for years to come. Also, be aware of local amendments to the NEC that may be in effect in your jurisdiction. These amendments may impose additional requirements or restrictions on grounding and bonding practices. It is important to stay up to date on any changes to the codes and standards that apply to your telecommunications system. Consider attending training courses or seminars on grounding and bonding to enhance your knowledge and skills. These courses can provide valuable insights into the latest techniques and best practices. Networking with other professionals in the telecommunications industry can also be a valuable way to learn about new developments and to share experiences. By continuously improving your knowledge and skills, you can ensure that your telecommunications system is always operating at its best. Furthermore, remember that proper documentation is essential for maintaining a safe and reliable telecommunications system. Keep detailed records of all grounding and bonding connections, surge protection devices, and inspection and maintenance activities. These records will be invaluable for troubleshooting problems and for demonstrating compliance with codes and standards. In conclusion, the use of bare ground wire in a telecommunications building entrance terminal is a violation of the NEC and poses a significant safety hazard. Replacing the bare ground wire with an insulated conductor is essential for complying with the code and protecting personnel and equipment. Proper grounding and bonding are crucial for the safe and reliable operation of telecommunications systems. By following the NEC requirements and industry best practices, you can create a safe and efficient system that will provide years of trouble-free service. The specific reference to NEC 800.100, subsection A, paragraph 1 highlights the code's explicit requirement for insulated or covered equipment grounding conductors in accessible locations. This provision is not merely a suggestion, but a mandatory safety measure. The rationale behind this requirement is to prevent accidental contact with energized conductors, which could lead to electric shock. Bare ground wires, by their very nature, offer no such protection. They are easily accessible and can be inadvertently touched by personnel working in the area. The consequences of such contact can be severe, ranging from mild shocks to serious injuries or even fatalities. The code also recognizes that bare ground wires are susceptible to corrosion and degradation. Over time, exposure to moisture, chemicals, and other environmental factors can cause the wire to corrode, reducing its conductivity and compromising its ability to effectively carry fault current. This can lead to a build-up of voltage on equipment enclosures, increasing the risk of electric shock. The use of insulated conductors mitigates these risks by providing a protective barrier against both accidental contact and environmental degradation. The insulation serves as a shield, preventing personnel from touching the conductor and protecting it from corrosion. In addition to the safety benefits, using insulated conductors also improves the reliability of the grounding system. By maintaining the integrity of the grounding conductor, the system is better able to effectively carry fault current and protect equipment from damage. When selecting an insulated conductor to replace the bare ground wire, it is important to choose one that is appropriately sized for the application and meets the requirements of the NEC. The conductor should be made of a corrosion-resistant material, such as copper or aluminum, and should be rated for the voltage and current that it will be carrying. The insulation should be suitable for the environment in which the conductor will be installed and should provide adequate protection against moisture, chemicals, and physical damage. It is also important to ensure that the conductor is properly installed and terminated. All connections should be clean, tight, and free from corrosion. The conductor should be supported at regular intervals to prevent sagging or damage. By taking these precautions, you can ensure that the insulated conductor provides a safe and reliable grounding path for the telecommunications system. The mention of a metal BET being energized during a lightning strike underscores the critical role of grounding and bonding in lightning protection. Lightning strikes can generate enormous amounts of energy, which can easily damage or destroy telecommunications equipment. A properly designed and installed grounding and bonding system can help to redirect this energy to ground, protecting the equipment from damage and preventing potential hazards. The earth electrode system serves as the primary grounding point for the building and provides a path for lightning current to flow to ground. The TNGB acts as the central connection point for all grounding conductors in the telecommunications system, ensuring that all equipment is effectively grounded. The bonding conductors connect different metallic parts of the system together, creating an electrically conductive path and minimizing the risk of voltage differences. By working together, these components of the grounding and bonding system provide a comprehensive lightning protection solution. However, it is important to note that no lightning protection system can completely eliminate the risk of damage. Lightning strikes are unpredictable and can sometimes overwhelm even the best designed systems. Therefore, it is also important to implement other lightning protection measures, such as surge protection devices. Surge protection devices are designed to protect telecommunications equipment from voltage surges caused by lightning strikes or other electrical disturbances. They should be installed at the point where the telecommunications cables enter the building and at other critical locations within the system. Regular inspections and testing of surge protection devices are essential to ensure that they are functioning properly. In addition to the technical aspects of grounding and bonding, it is also important to consider the human element. Personnel working on telecommunications systems should be properly trained in grounding and bonding procedures and should be aware of the potential hazards. They should also be equipped with the necessary safety equipment, such as gloves and safety glasses. By creating a culture of safety and providing adequate training and resources, you can minimize the risk of accidents and injuries. In conclusion, the use of bare ground wire in a telecommunications building entrance terminal is a serious violation of the NEC and poses a significant safety hazard. Replacing the bare ground wire with an insulated conductor is essential for complying with the code and protecting personnel and equipment. Proper grounding and bonding are crucial for the safe and reliable operation of telecommunications systems and for providing effective lightning protection. By following the NEC requirements and industry best practices, you can create a safe and efficient system that will provide years of trouble-free service.